lesson. I'm teacher Agnes, and today we are going to discuss how we can approximate decimals. Now we have several methods of approximating decimals, and one of them is through rounding off. So rounding off is one of the methods of approximating decimals or even other numbers. Now the type of decimals that you can round off are the decimals that are either non-terminating decimals, or they are recurring. So we mentioned these decimals in the previous video. Non-terminating decimals are the decimals you get that never end. If you divide a number by another one, you get a decimal that is not coming to an end. And then a recurring decimal is one that is also not coming to an end, but maybe there's one or two numbers that are being repeated over and over. Now, in a case where you have done a calculation in your calculator and you have obtained either a non-terminating or recurring decimal, when you record your answer, you do not need to record the full answer shown in the calculator. You will need to round off and record a part of that decimal. Then sometimes your teachers will be very specific. They'll ask you to give your answer maybe to 1 decimal place or to 2 decimal places, and so on. Before we start rounding off, you need to remember what is a decimal place. If you have a decimal like 4.06, how many decimal places does it have? The decimal places are the numbers that come after the decimal point, to the right of the decimal point. So in this case, we have 2 decimal places. So now, if you are asked to approximate this or to round off this decimal to 1 decimal place, what do? So from where we have the decimal point, you count. This is 1. So this is a number that has 1 decimal place, only has 1 number after the decimal point. So we count the first one, put a line on it, and then check the next number, which is 6. Now, if the number, so follow the instructions here, check, we want to approximate to round off to 1 decimal place. So we count to the first decimal place. In this case, it's here at 0. So at this point, you check the number that comes after 0, and if it is 5 or more than 5, then you round it up such that you add 1 here. And if it is less than 5, you round it down by just cutting it off. So we will do an example to show that. So in this case, we will round it up because 6 is greater than 5. So we'll add 1 here, and the answer here will be 4.1. Let's look at another example. Let's round off 346.781 to 2 decimal places. This means that our answer should have how many decimal places? 2. So we count from where we have the decimal point towards the right. We count 1, 2. Then we check the number that is the third decimal, that is the third place. So if this number is less than 5, what do? We cut it off. So 1 is less than 5. So we cut it off, and our final answer will be 346.78. Now let's look at this example, 60.009, and then you need to round off to 1 decimal place. So at this point, we check from the decimal point towards the right, we count 1 because we want 1 decimal place. Then you slash there, look at the next number, which is 0. Now 0 is less than 5. So what do? We cut it off. So our answer will be 60.0. So make sure that you write the point 0, even if it doesn't give any value to the number. But because the instructions need 1 decimal place, then you must put the point 0. Now what if you have a number like 0.006 7, 6, 9, and then you write this correct to 2 decimal places. Okay, 2 decimal places. So when counting, the zeros must be counted. So after the decimal point, the first place is this one. So 1, 2. Then you slash there. So looking at 7, it is greater than 5. So you round it up. So we add 1 here. So the answer will be 0.01. So now, this is not the only method of approximating, of making approximations. We have another method in which we consider the number of significant figures, and that is what we are going to look at next. Now, for us to approximate using significant figures, there are a few rules that we must understand so that we follow them and be able to make approximations using significant figures. Now, which numbers or which digits are considered significant in a number? So the first rule that you must remember is that all non-zero digits are significant. All non-zero digits are significant. Okay? An example, if we have a number like 327, non-zero means, a digit that is not 0. So 3 is not 0, 2 is not 0, 7 is not 0. So all these non-zero digits are significant in this number. Therefore, we can say that this number has 3 significant figures. Got it? Alright. Now, any zero or zeros between non-zero digits, zeros between non-zero digits are significant. Okay? What do we mean? So if you have a number like 401, the zero is between 2 non-zero digits. So this zero is considered significant. So how many significant numbers does this significant figures does this number have? 3. So this is 3 significant figures. What if you have a number like 7.067? Okay, you notice that the zero is between 2 non-zero digits. Therefore, the zero is considered to be significant. So the total number of significant figures that we have here are 1, 2, 3, 4. 4 significant figures. So when is zero not considered to be significant? So if zeros are zeros on the left side of the number, are considered to be insignificant. Are insignificant. Okay? For example, if I have 0.4, this 0 is not significant. It's on the left side of the number, and there is no non-zero digit before it. So this 0 is not significant, and the total number of significant figures here will just be 1. Therefore, will be considered as significant. Another example is 0.0078. So these zeros are on the left side of the number, and there is no non-zero digit before them. So that makes the 3 zeros insignificant. So when we count the significant figures in this number, we begin from 7. So 1, 2. So the significant numbers here are 2. Okay? Then the final rule is that zeros that are on the right side of the number, so zeros on the right hand side of the number may or may not, okay, may or may not be significant. So when are they considered to be significant, or when are they considered to not be significant? So we are going to look at two examples. A number like 4,600 has got two zeros. So these two zeros can be here for two reasons. One, either because they are considered to be significant, or because they represent the value of the number. For instance, if I want this number written correct to two significant figures, we always count from the left. 1, 2. So these are the first two significant figures. So if I write 46, I will have not represented the value of the original number. I will have lost the value of the original number, because remember, writing numbers correct to a certain number of significant figures is a method of approximation. So does it make sense to approximate 4,600 to 46? It doesn't make sense. So to ensure that the number does not lose its value, I will add the two zeros. But remember, the instruction was to write this number correct to two significant figures. So these two zeros here are there in the number for the value, not as significant figures. What if I want to write the same number correct to three significant figures? So we will count 1, 2, 3. This gives us 460. So the zero has been counted as a significant figure. But still, you cannot approximate 4,600 to 460. So this zero that we have left out must still be written to ensure that we retain the value of the number. So this zero here is counted as a significant figure, but this zero here is not counted as a significant figure, but it is there to retain the value of the original number, which is being approximated. Now, having known these rules, we are going to do some examples and see how we actually approximate using significant figures. So, when writing a number correct to a certain number of significant figures, we start counting from the left side of the number. So, we start counting from 2. So, since you can see that this number is formed by non-zero digits, so at this moment, all these digits are significant. So as the number is right now, how many significant figures does it have? 1, 2, 3, 4. But we want to shorten it and approximate it correct to 3 significant figures. So we start counting from 2. So 1, 2, 3. We check the next number, which is 9. Is 9 greater than or less than 5? 9 is greater than 5. So we round it up. So we add 1 here. So the final answer will be equal to 26.1 plus 4 is 5. And that is our answer. Now let us look at another example. 507.1 correct to 2 significant figures. So even before we answer it, how many significant figures do we have here? Zeros can be confusing, but if you remember the rules, then it will be very easy. The zero that we have here is in between non-zero digits. And we said any zero that is in between non-zero digits, it's considered to be significant. So as the number is right now, we have 1, 2, 3, 4 significant figures. So if we want 2, we must begin from 5. 1, 2, cross there. So looking at 7, is it greater than or less than 5? It's greater than 5. So we round it up, okay? So this will be equal to 5. 1 plus 0 is 1. If we leave our answer like that, Will it be correct? No, it won't, because remember this is a method of approximation. So can we approximate 507 to 51? Nope. So what do? This digit here will be converted into 0, or rather we will add a 0 to maintain the value of the number, because it now makes more sense to approximate 507.1 to 510. So this 0 here is in this number for the sake of the value of this number. But the significant figures are 2, 5 and 1. Remember we said a 0 that comes on the right side of the number may or may not be significant. So when it is not significant, it is there for the sake of the value of the number. All right, let's look at another example. 0.00781 correct to one significant figure. Good. Now, the way the number is right now, how many significant figures does it have? So remember the other rule that any 0 to the left of the number is not significant. So this 0, this one and this one cannot be counted as significant figures. We will begin counting from 7. So 1 and then we slash. Looking at 8, 8 is greater than 5, so we round it up. So we add 1 here and then we will have 0.008. These zeros must be written, because if you ignore them and write the answer as just 8, you will have lost the value of the number, because you cannot approximate 0.00781 to 8. Impossible. So the 3 zeros must be written for the sake of the value of the number. All right, let's look at another example to ensure that we get to understand all the rules. So if you have 56,129 and then you write this correct to 2 significant figures, what will be the answer? Now, all these digits in this number are non-zero digits. What does that mean? That if they are non-zero digits, then they are all significant. So as the number is right now, it has 1, 2, 3, 4, 5 significant figures. So we start counting from 5. 1, 2. We need 2 significant figures. Put your line there. Then look at the next number, which is 1. Now 1 is less than 0, is less than 5. So we cut it off and make it a 0. So this now will become 56, okay? But since this is 56,129, we cannot approximate it to 56. So we need to add zeros equivalent to the number of digits that we have remaining. So 1, 2, 3. So now 56,129 has been approximated to 56,000. Good. Now, another example is write 21 correct to 3 significant figures. Okay? Now, already as 21 is, it has 2 digits, which are non-zero digits, which means that it has how many significant figures? 2. So we need 3. So how do we move from 2 to 3? Easy. So this is 21.0. Okay? So you must put a point. You can't just add a 0 without the point, because you need to retain the value of the number. 21 written as 21.0 is the same thing. But 21 written as 210 is not the same thing. You will have changed the value of the number. So this is the correct way of writing 21 correct to 3 significant figures. You just add a point and a 0. So the 0 is counted as a significant figure. Okay? Now, having done all these examples, I'm going to give you an exercise that you are going to use to test whether you have understood how to, use each of the four rules that we have given that must be used to determine the number of significant figures in a number. You will attempt these questions to test whether you have understood the concept of writing numbers correct to a given number of significant figures. So in the first one, you will write 418.27 correct to three significant figures. 2, 603.7 correct to two significant figures. C, 27,300 correct to two significant figures. 0.00018 correct to one significant figure. 46 correct to three significant figures, and finally 14,127,181 correct to four significant figures. So feel free to refer back to the rules that you wrote down, and then when you are confident enough that you understand each rule, come back and attempt the questions. Now don't go away, because we are about to find out how else can we simplify numbers that are either too big or too small, so that it is easy for us to communicate to other mathematicians, or even just for simplification or working them out. By now you know that science and math coexist. Did you know that the distance from the Sun to Neptune is one of the planets that we have in our solar system. Did you know that the distance from the Sun to Neptune is 4,473,700,000, okay, kilometers. That is the distance between the Sun and Neptune. When you look at this number, you realize that this number is a big number. So when you are writing it down, or when you are communicating it to someone, it will be tedious for you to communicate it. So numbers that are either too big or too small can be written in standard form. Okay? So what is this standard form? How does it look like? How do we, apply it? So the standard form is in the form A times 10 power n. Now, A represents any number that either is equal to 1 or greater than 1. So A can be greater than or equal to 1. Or A can be less than 10. So any number like 1, 1.2, 2.5, 9.7, numbers that range between 1 and are less than 10 are the ones that we use in place of A. Then N represents all integers. It can be any integer. So it can be a negative number, it can be 0, it can also be a positive number. Now for us to be able to understand how to write standard form, I want us to write some of these numbers in a different way. Now, looking at a number like 1,000, this 1,000 can be written in form of 10. Remember, our focus is on the 10 power something. So 1,000 is equal to 10 times 10 times 10. If you multiply 10 3 times, because we have 3 zeros, then you get, 1,000. Now, 10 times 10 times 10. This is 10 multiplied how many times? 3. So this can be written as 10 power 3. Now, what about a number like 100? This will be equal to 10 times 10, which is equal to 10 power 2. 10 alone is just 10, so this is 10 power 1 because it's just 1. Then, if you have something like 0.1, 0.1 is the same as 1 over 10. So this is equal to 1 over 10 power 1. So if you want to remove the fraction, then you must add a negative to the power. So this will become 10 power negative 1. Okay, so any number that is less than 1, when written in standard form, the power will always be negative. Let me repeat that. A number that is less than 1, when written in standard form, the power here, this value of n, will always be a negative integer. But if a number is greater than 100, greater than 10, like this 100, the power will always be a positive. So when is the power 0? We're going to discuss that as we do some examples. Now, in this example, we are going to check what is the standard form of the following numbers. So let's start with a simple one, a number like 0.4. Now 0.4 is not in standard form because we said for a number to be in standard form, let me rewrite that form here, a times 10 power n. This value a must be between 1 and 9.99999 and so on. So 0.4 is less than 1. So we need to move the decimal point forward so that we can make this number be between 1 and 9. So if we move the decimal point forward, we will have 4, okay, times, we say a number that is less than 1 will always have a negative power. So this will be times 10 power. How many times have we moved the decimal point? Once. So this will be equal to power negative 1. So 0.4 is not in standard form because 0.4 is not within the required range for A. A needs to be between 1 and 9.99. So we need to move the decimal point forward so that now we create a 4, which is in the correct range. Then we multiply by 10 power negative 1 because we have moved the decimal point forward once. Now, how else can you do this? Now, 0.4 as a fraction is the same as 4 over 10. And 10 is raised to power 1. So this is the same as 4. Remember what we said in the previous slide, that if you want to bring 10 power 1 to the numerator, then you must add a negative to the power. So this will be 4 times 10 power negative 1. Let's do another example for a number that is less than 1. If you have a number like 0.00285. Now this number, for it to be in standard form, then the decimal point will need to be between which numbers? The decimal point needs to be somewhere such that the number we form will be between 1 and 9.999. So we need to move the decimal point to where we have 2, 1, 2, 3. We need to move it here. So as now we form the number 2.85. 2.85 is between 1 and 9.99. So this will be equal to 2.85 times. How many times did we move the decimal point forward? 1, 2, 3. So times 10 power negative 3 because this number was less than 1. So the power will be negative. What if we do it using this approach? This will be, how many decimal places do we have here? 1, 2, 3, 4, 5. But we want to move our decimal point to where we have 2. So how many times do we have to move? 1, 2, 3. So this can be written as 2.85 over, how many times have we moved? 3 times. So which number begins with 1 and has 3 zeros? 1000. Okay. Now this will be equal to 2.85 over 1000 written in terms of 10 will be 10 power 3. And this will be equal to 2.85 times 10 power 3. If you bring it up, this will be negative 3. So whichever method works for you, choose the one that you resonate most with. So let us check when We are going to do some examples and see when we usually have 10 having a power of 0. So in this case, 10 has the power of a negative number. So when does 10 gain a power of 0? Okay, so now we're going to do these two examples. If you have a number like 5, just 5, okay? How do we write it in standard form? So 5 already fits the definition of A because A should be a number between 1 and 9.9. Now 5 is in between. So we don't need to move the decimal point either forward or backwards. So this is just going to be 5 times 10 power 0 because you have not moved the decimal point. If you have a number like 3.2, again 3.2 is in between 1 and 9.999. So 3.2 fits the definition of A. We don't need to move the decimal point forward or backwards. So then you just add times 10 power 0 so that it meets this structure. So anytime you don't move the decimal point either forward or backwards, the power on 10 will always be 0. When is the power usually positive? If you have a number that is greater than 10, for instance, if you have 12, okay? Now, a number like this, we assume that the decimal point is here, 0.0. Now, 12 is not in the range of 1 to 9.99. So we need to move the decimal point backwards here so that it fits this range. So this will be equal to 1.2, okay, times 10 power 1 because we have moved the decimal point one step. And because 12 was greater than 10, then the power is positive, okay? Yes. Now, if you have a number like 560,000 and you need to write it in standard form. So the decimal point is here. So we move it backwards how many times? 1, 2, 3, 4, 5. So this will be 5.6 times 10 power 5. Finally, one more example. Remember what we gave as a distance between the Sun and Neptune? Oh, that was 4,473,700,000. So how do we write this in standard form? So we check the decimal point is here. So we move it backwards how many times? 1, 2, 3, 4, 5, 6, 7, 8, 9. So this will be 4.4737 times 10 power 9. So wouldn't it be easier to say that the distance between the Sun and Neptune is 4.4737 times 10 power 9? It would. Having understood how we write numbers in standard form, write the following numbers in standard form. Number 1, 0.000273. Number 2, 185,000. Number C, 4.78. And finally, 14. Thank you for being in this lesson. See you in the next lesson.